Click the bell icon to get latest videos from Ekeeda.
Hello friends, in today's session we are going to cover the process of ion exchange process. In the previous session we already saw what exactly ion exchange process is, but now how is it done will be covered in today's session. Ion exchange process part 2. Process of ion exchange process. This process is also known as demineralization process because we are going to take out all the minerals which are present in water. Ion exchange process part 2. Process of ion exchange, also known as demineralization process. That means we are going to take out all the minerals which are present in the water. Demineralization means removal of all the minerals present in the water. Now, if I have soft water and I add certain minerals inside it, those minerals will get converted into ions because they will dissociate into water. Now, this ions leads to hardness of water. If I remove all the minerals present in the water, then all the hardness of the water will be gone. And that we are going to do in this ion exchange process. The hard water is first passed through a cation exchange column and then through an anion exchange column. Let us first see this cation exchange, what exactly these columns are. Cation exchange and anion exchange. Cation stands for positive ion and ion stands for negative ions. Now there can be two types of ions when a salt dissociates. For example, let us take NaCl. When I have NaCl and I put that into water, the polar solute NaCl will get dissolved in the polar solvent water, and that NaCl will get dissociated or broken down into Na plus and Cl minus. Now Na plus has a positive charge because it has given one electron to Cl minus, and since Cl minus has accepted one electron, it has a negative charge. So Na plus, any ion with a positive charge, is known as a cation, and Cl minus, any ion with a negative charge, is known as an anion. Generally, my hard water always contains two types of ions, cations and anions, both of them, because the salts will always dissociate into something positive and something negative. So let us see the cation exchanger and the anion exchange column. Now in this diagram, the exact ion exchange process takes place. This is my hard water inlet. It is first going into a cation exchange bed, and then from here it passes through here and comes to my anion exchange bed, and then I have this regeneration happening over here. Thus, the water coming out of the anion exchange bed becomes free of cations as well as of anions. Why? Because in the cation exchange, what we are doing is we are taking away all the cations present in the water. In the anion exchange bed, we are taking away all the anions present in the water. So, after the water has passed through the cation exchange bed as well as the anion exchange bed, the water becomes free of both the ions, that is the positive ions as well as the negative ions. The resultant ion-free water is deionized water or demineralized water. That means the resultant water that comes finally after the ion exchange bed is either known as ion-free water. Why? Because it does not have any ions in it. It is also known as deionized water because it does not have neither cation nor anion in it, or it is known as demineralized water. The water is finally freed from dissolved gases by passing it through a degasifier, which is a tar heated from both sides, and a vacuum pump. So now first I have hard water. This hard water contains both the ions, positive ions and negative ions. It contains cations and anions. Now these cations pass through the cation exchange bed and get removed over here. Then the water, which contains only the anions, passes from here and it goes to the anion exchange bed. Over here the anions are also removed out. After that, the water which I get out of this water over here, out of it, is known as deionized water or ion-free water or demineralized water. That means that water is free from all the ions, the positive ions as well as the negative ions. But we should understand that not only minerals but also gases contribute to the hardness of water. That means there can be certain amount of gases, dissolved oxygen or dissolved carbon dioxide, which leads to contamination of water and which eventually leads to the hardness of water. And thus we should have a degasifier. Now degasifier is nothing but a sort of container. Over here all the gases are being removed, and over here this degasifier also has vacuum pumps in it. Now how exactly this degasifier works? It works on two principles. The first is temperature, the second one is pressure. High temperature and low pressure reduces the quantity of dissolved gas. It's very important to understand that whenever a temperature is high, the dissolved gas will bubble out. So for example, let's take water which has dissolved carbon dioxide in it. Now this dissolved carbon dioxide is in water which is at room temperature. As soon as you start boiling the water, carbon dioxide will bubble out immediately. So high temperature as well as low pressure, whenever we make aerated drinks, what do? Is we put pressure on the gas and then we put that pressurized gas into the water. That means high pressure leads to dissolution of carbon dioxide into water. But once we give low pressure to them, that means no amount of pressure is given to them. That means at low pressure, carbon dioxide will have to bubble out. High temperature and low pressure will make a point to degasify the water immediately. Water obtained by this process reduces the quantity of impurities and is very near to distilled water. Finally, the water which we get, it's free of cations, it's free of anions, and it is also free from gases which contribute to the hardness of water. That means this is absolutely pure water. It's as good as distilled water. This process is very good for high pressure boilers. Now let us see the regeneration of exhausted resins. First, let us see the resins in the diagram. So over here, I have a cation exchange bed, anion exchange bed. What does this do? This does ion exchange. That means the positive ions present in the hard water are taken away by this cation exchanger, and in exchange it will give away its harmless ions. That means if it is taking away the harmful ions from the water, in return it is giving its own harmless ions. The ions given by the cation exchanger do not contribute to the hardness of the water at all. That means after some point of time this bed will get exhausted because it will not have anything to give. The only thing it will have is the positive ions taken by the hard water. And once this entire bed gets exhausted, it cannot refine or it cannot purify more water. The same thing happens in the anion exchanger. Anion exchanger is water having negative ions. This water having negative ions, so now the water which passes from the cation exchanger into the anion exchanger will only have negative ions. So this my anion exchange bed will take away its negative ions and in return will give some other ions which are already present in it. And that's the reason why the name ion exchange, taking away the ions which are present in the water and giving out ions which are present in the bed. Now these ions given by the anion exchange are harmless ions. That means these ions will not contribute to the hardness of the water at all. But after some point of time, even this anion exchange bed will get exhausted because all the ions it had exchanged had already exchanged. The ions it now has are the anions which were present in the water, and thus it cannot refine or purify the water anymore. So after a certain point of time, we will have to regenerate the cation exchange bed as well as anion exchange bed. What is regeneration? Providing the original ions to the bed is known as regeneration. We will see the process of regeneration for both the cation exchange as well as the anion exchange. Regeneration of exhausted resins. Now these resins are nothing but the cation exchange bed and the anion exchange bed. The capabilities of these ion exchange resins to ions from hard water is based on their ion exchange capabilities. Let us see the ion exchange capabilities of cation exchanger and anion exchanger in detail. When their ion exchange capacities are lost, they are said to be exhausted. When the resins are exhausted, the supply of water is stopped. The exhausted cation exchanger is regenerated by passing dilute HCl or H2SO4. So to that exhausted cation exchanger, we can either pass dilute HCl or H2SO4 and we can regenerate it. Let us see the reactions for the same. The first one we have RCA or RMG. Now this RCA or RMG is nothing but exhausted cation exchange bed. To this I am passing 2 HCl. This entire process is known as the regeneration process. It forms 2 RH. That means, let us first take an example of RCA. This RCA moves with this 2 HCl. Now this 2 HCl has 2 hydrogens and 2 chlorines. Out of those 2 hydrogens, the entire 2 hydrogens go get and attached to this R, forming 2 RH. What is remaining over here is Ca and 2Cl. This Ca and 2Cl forms CaCl2. This hydrogens and this R form 2RH. Now let us see the balancing of this reaction. Whenever we do the balancing of the reaction, we do not consider R, because R is the exhausted cation exchange. It can be in any amount. But the HCl which we have given should be balanced. So this R will not be balanced in either of the reactions, but the HCl will be balanced. So let us see RCa plus 2 HCl. So we are not considering R for balancing. So here we'll see the balancing of HCl. We have 2 hydrogens on my reactant side, 2 hydrogens on my product side, 1 calcium on my reactant side, 1 calcium on my product side, 2 chlorines on my reactant side, 2 chlorines on my product side. We can do the same reaction with the help of RMG as well. So this is RMG. Again, we will not balance R. So it will be RMG plus 2 HCl giving us 2 RH. That means both the H's over here will go and get attached to this R. And whatever is remaining, that is Mg and 2Cl, will form MgCl2. Balancing of it, we will not consider R over here, but the 2 H's over here will be 2H, 1 Mg will be 1 Mg, 2 chlorines on the reactant side forming 2 chlorines on the product side as well. We'll see the next reaction. The first reaction was with dilute HCl solution. The next reaction is with dilute H2SO4 solution. Starting off with RCa plus H2SO4, the process is known as the regeneration process, forming 2RH plus CaSO4 or MgSO4 if we use RMG over here. So this RCa plus H2SO4, both the H's over here go and get attached to this R, forming 2RH, and this I have Ca and SO4 forming CaSO4 over here. The balancing of it, we won't consider the R over here. We have 2 hydrogens on the reactant side, 2 hydrogens on the product side as well. I have 1 Ca on the reactant side, 1 Ca on the product side. After both of these hydrogens getting attached to the R, what remains over here is just SO4. So this SO4 goes and gets attached to this Ca, forming CaSO4. The same reaction can be done with RMG. So over here I have RMG, 1 R and 1 Mg with H2SO4. Both of these hydrogens will go and get attached to this R, forming 2RH. Whatever is remaining, that is Mg from here and SO4 from here, will form MgSO4. Balancing it, again we have 2 hydrogens over here, 2 hydrogens over here. We have 1 SO4 and 1 Mg on the reactant side, forming MgSO4 on the product side. Now let us look at the exhausted anion exchanger that is regenerated by treating it with dilute NaOH. So over here we have taken R-Cl2. Now this is a part of my exhausted anion exchange column or the resin. We can also call it as the anion exchange bed, plus 2 NaOH. This process is known as the regeneration process. It forms R-OH twice plus 2 NaCl. Let us see the balancing of this entire reaction over here. We have 1 R- over here, 1 R- over here. We have 2 chlorines on the reactant side, 2 chlorines on the product side. We have 2 NAs on the reactant side, 2 NAs on the product side. 2 OHs on the reactant side, OH twice on the product side. So what exactly happens during this regeneration reaction is this OH, both the OHs over here go and get attached themselves to this R-. Whatever remains over here is 2 chlorines and 2 NLs forming 2 NaCl. The next over here is R-SO4. Again, this is from my anion exchange bed. To this we are adding a NaOH solution. The process is known as the regeneration process. Forms R-OH twice plus Na2SO4. First, let us see the balancing of the reaction. We have one R dash on the reactant side, one R dash on the product side, one SO4 on the reactant side, one SO4 on the product side. Then we have two NaOH, that means two NAs on the reactant side, Na2 on the product side. The sodium is also balanced. And two OHs on the reactant side and OH twice on the product side. So OH is also balanced. Now in this entire reaction, what happens is both the OHs over here go and get attached to this R dash, forming R dash OH twice. And what remains is 2 Na and 1 SO4, forming Na2SO4. The exchanger bed is washed with deionized water, and washings containing NaCl or Na2SO4 are passed to the sink and drain. The regenerated ion exchange reagents are used again. The water contains sufficient temporary hardness. It is advisable to remove such hardness first by treating them with lime. That means finally the water that we get, we can either treat them with lime or we can have some physical methods for removing the temporary hardness, that is boiling. Now we have a diagram which explains the entire ion exchange process. It starts from here. Over here first we have raw water inlet. Now this raw water has everything. It has the cations, it has the anions, it also has the gases present in it. So it is mineralized, it is impure and it is hard because of the ions and the gases over here. So now this raw water goes inside, and over here they have shown mixed ionizer bed. That means it has cation bed as well as anion bed. They have not shown this in detail because this is a summary of the entire process. So the raw water first comes from here, it goes into the cation exchange bed, all the positive ions are taken away. Now the water containing only the negative charge goes inside the anion exchange bed. From here all the negative charges are taken away. That means the positive ions are taken away and the negative ions are also taken away. We have no ions left in water. That means it is ion-free water, deionized water, also known as demineralized water. And this demineralized water comes out from here. This is the entire ion exchange process which they have shown over here in part A. Because of this or due to this, what happens is exhausted mixed ionizer beds. That means after this entire process, the water which I get is demineralized water or the water without any impurities. But the problem is the beds get exhausted. The beds are nothing but the resins, the cationic resin and the anionic resin. That means the positive cation bed and the negative anion bed, both of them get exhausted. That means the positive cation bed and the negative anion bed, both of them get exhausted. They get exhausted by doing the ion exchange. That means they have given away all of their ions, but they themselves have the ions of the impurities present in it. And thus, two main things are done over here. That is, compressed air is passed and backwash water is passed. Over here, the compressed air which is passed into the cations and anions and the water which is passed into the cations and anions will help in removing all the impurities present in the exhausted bed. Now, what are the impurities which are present in the exhausted bed? Those are the ions, positive ions and the negative ions which were present in the water. Once this is done, finally, we have an exchanger or regeneration process. Now, for this regeneration process, for the anion exchangers, we either put NaOH or Na2SO4. For the cation exchanger process, we put H2SO4 or HCl. Once this is done, finally, we can wash the sink. Washing the sink and we get our beds regenerated again. These beds can again be used over here. Again, they can be cleaned over here. Again, regenerated over here. Used, cleaned and regenerated again and again, and this process can go on, purifying a lot of hard water into soft water. This is the entire ion exchange process. So in today's session, we studied the entire process of ion exchange. We studied about the cationic bed, the anionic bed, and how the exchange of ions lead to the exhaustion of those two beds. After that, we studied about the regeneration of the beds. And finally, we studied the entire diagram which contains the entire ion exchange process. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.